Okay, so we're going to talk about different types of components today used in general circuitry. I'm just going to talk about a few of them general types that you'll run across. We'll start with resistors. This one is a photoresistor, and it works by way of light. If it's when light hits it, it tends to change the resistance value. If you notice real close, you can see that the squiggly line in the surface of that. When the light hits that surface, it changes the value of the resistor. And this one here is a fixed resistor, and that one is a general purpose resistor, a quarter watt approximately, and that's usually used in most general purpose circuits. This one here is a variable resistor, or potentiometer we call it, and it has a adjustable knob that changes the resistance value. So let's say if we have like most resistors, general resistor, usually the schematic design is like this. That'll be like this for this resistor, this type of fixed resistor type. But whenever there's a potentiometer in the circuit, it's usually noted by having a little arrow right above these squiggly lines, and that arrow means it's variable. It tells you that, you know, this pin, and this pin is a 3-pin unit. Makes it variable. As I'm going to pull out here, as you can see in the bottom, there's 3 pins, 1, 2, and 3. And those 3 pins can, you make up the resistor. The 2 end pins make up the total resistance. Like this one's a 10,000 ohm resistor. From here, from this point to this point is a 10,000 ohm. But if you tap it here at the adjustable pin and this pin, you can change that 10,000 down to 5,000 or less. That's what makes it adjustable. On the other hand, when you have the photoresistor, it has a symbol that's usually you have a circle, and inside there they have a little resistor like this, squiggly lines. Then they have an arrow with a bone, arrow that you use for a bow going through the symbol. That stands for photo resistors. And that's what that type is. And that one reacts to light generally. Our next item that we usually face with when we're dealing with circuitries are capacitors. And capacitors are responsible for making varying charging times. You have your electrolytic capacitors and you have the ceramic capacitors. These electrolytic capacitors are polarized. They have a negative and a positive lead on it. So that means they're polarized. Most ceramic capacitors are not polarized. You can put them in any direction you like. Most general electrolytic capacitors used in circuits start at like 47 microfarads to 100 microfarads, like this one. And they're used to either smooth out a signal or to as an RC charging circuit. And let me see here, we also have diodes, which are light emitting diodes, or what they call LEDs. And LEDs generally give off light when power is applied. And they can be used for indicators, you know, things like letting you know when something is on or when something is off. And these diodes usually run off of 1.3 volts to 1.7 volts DC. And this particular one here is a photodiode, and it's mostly used for when light hits it, it can switch. It works as a switch, kind of like an NPN or PNP transistor does. And the symbol for that one is usually, you got a circle, and then you got your little middle point, then you got your emitter pin. In this case, this would be NPN transistor, and then you got your collector here, and this would be your base. But you notice there's no base pin because light made by these 2 arrows here is what turns it on versus a pin. So when light hits it, it changes the state of this transistor. It can open or close the circuit to make a complete circuit. So that's what that's for. Our next item we have here is a infamous 555 timer chip. And I'm sure you've seen this in many circuits. And it has it's an 8-pin chip. is 1, 2, 3, 4, 5, 6, 7, 8. If you count them in reverse clockwise direction. And this is using multiple timing circuits where you need timing control. You can use an IC like this known as a 555 timer. They have a dual package like this known as a 556, and that would be something like this. And it has 16 pins. And pin 1 also starts from the same, like you find the little notch in the chip. The pin right to the left of it is pin 1. You count that around and you'll get to 16. And this is a 556 IC chip. It's just 2 of these in one package, which is good sometimes when you need that. We're going to talk about relays. We have some relays here. Relays are very handy in circuitry. They have, this one happens to be, you can look from the pins and tell how many contacts it has. It's 5 pins altogether, but 3 of these pins here control the little lever. So let's say if we draw a little relay here. I'm going to draw a little relay for you. And I'm going to show you what each kind of does. Alright, this one have a spring on it or whatever. Okay, now this would be a single pole double throw relay. Reason being because the when the relay is in the relaxed state, it's usually sitting on the top pin, is usually connected. The bottom pin usually not connected until you apply energy to the coil. Then it would draw it to the it'll draw it down to the next pin. So let's say if these pins were connected, these two would be not connected until power is applied at these 2 pins. And then that would make the relay function according to how you got it hooked up. And as I said, this is a single pole double throw. They have double pole double throw, and that would just mean 3 more of these pins here will be laid out here somewhere. And but this is a single pole double throw relay, or like a switch pretty much. We also have a regular switch that's a push button dip type switch, and it can fit into like just a second, like little circuit boards like that. And it's a dip type, so you can just put it right into the circuit that you're designing. And this one has the ability, you can switch it on and off. You hear that? I switch it on and off, and it's a momentary switch. And it switches on and off, and that's usually a single pole type switch. And you know, you switch it on and off by pressing it. Then we have, sometimes you might be faced with, in your circuit, you might need a diode. And this one here is an N4002. It's a general purpose diode. And what diodes do, they kind of limit direction of a voltage. Let's say if you send a voltage through something. Let's say you're sending water through a pipe, we'll just say, and it has a one-way valve. Well, water is able to flow this direction, but not able to flow up this direction. The flap would come down. If it flows one direction, it opens the valve, letting the water go through. If you try to send water the other way, it stops it. So that's what mainly diodes do. They kind of block current in one or two of the directions. So those are very handy. Diodes can also be used to rectify a signal. So if you have an AC signal, AC usually works by traveling both directions. You know, you got go in this direction, go in that direction. AC removes one of the directions and make it the energy just be collected by one direction. If you make a bridge rectifier with these, you would need 4 of these, and you can make what's known as a bridge rectifier, and that would make a cleaner signal of DC for you. And then we have an NPN transistor, and the NPN transistor has a symbol that looks like this. You got the little thing there, got your little arrow, your emitter, there's your collector, and you got a base pin. So that'll be your NPN. If this arrow is facing the other way, like this, arrow facing in, this will be a PNP transistor. And they both are used primarily the same way, depending on which way is ground and positive in your circuit. So that's what would dictate which one you might want to use. those are just some of the practical components you will find in most circuits. As we build circuits on this channel, you'll see me using an array of these, assortment of these parts. And I just wanted you to know a little bit today as to what their function is and why we're using them. So when you see them in a circuit, you have a kind of an idea of why we're using it. So that concludes my video for today. I know it's short but sweet. And I hope you learned something, and I hope you tune in again. Be sure to hit that subscribe button. Bye.